Okay, welcome back. Now what we're going to do is we're going to talk about two types of speed when we're dealing with circles, okay, and angles. One is linear speed, and the other one is called angular speed, okay. Now think of linear speed the same way that you think about driving your car and the speed that you're going in driving your car. It's the speed or the rate of change in distance along a straight path, okay. Now we can look at linear speed the same way as on a circle, but it's on a curved line instead of a straight line, but it's the same thing. It's linear speed because how fast this is moving. Let's say if we have a dot, we mark a tire, right? Let's say this is a tire. We mark with chalk, yellow chalk, on one spot on the tire. Well, as that circle, that bicycle is going down the street at, let's say, 3 miles per hour or 5 miles per hour, let's say, this dot, the chalk line, is going around the circle at the same rate, right? Because again, it's as if you were able to unwind the tire. It's covering the same distance as it meets the road, right? So the distance it's going as it goes every revolution of the tire is about how far it's going, right? So if it's going 3 miles per hour, then every hour that tire is moving or covering 3 miles, okay, in circumference or in linear distance, okay? Now, the other way to look at it is anytime, let's say you had something tied to a rope and you're spinning it in a circle, if you were to let go of that rope at any point, let's say you're just spinning it around your head or just twirling it around and it's going in a circle, but at any point that you let go, it's going to go off at a right angle. It's going to go off in a linear direction. So if you let go at this point right here, it's going to go along this line here. Or if you let go here, it's going to go along this line. That's the other way to look at linear speed, okay? Because the only thing keeping it on the circular path is this rope, okay? Otherwise, it'd just go in a straight line, okay? So that, I hope, helps you understand what I mean by linear speed. It's the distance, it's the rate of change in distance over time as this follows the path of the circle. Okay? Now, angular speed has to deal with the angle, the change in the angle over time. So that would deal with theta. How fast is theta changing with respect to time? That would be angular speed. Okay, so now, what are the formulas? Well, linear speed is distance over time, right? Think of what we normally deal with when we're dealing with driving cars and stuff. We say distance is equal to rate times time, right? Linear distance is equal to how fast you're going on average times the amount of time it's taking you, okay? So what does that mean? R, the rate, is equal to distance over time. Well, guess what? That's also the same formula that we use for linear velocity. Okay, so linear speed. Linear speed is given by this formula. The distance traveled divided by the amount of time that's lapsed. Okay, now, compare that to angular speed. Angular speed, which we use the Greek letter omega, lowercase omega, is the change in angle, theta, over time. And that's it. So this is linear speed. This is how we calculate angular speed. Okay, let's do some examples.